right? So when you are training a neural network, what you have to do, you have to like have this kind of a past data. So this should be like real data set, right? A real data set, and you have to collect this data set, uh, real past data set, and we are going to apply those features into the neural network from here and the other feature. So we are going to like take a one row and apply those values here, right? And then after applying those values here, this neural network will forward propagate, right? The values will be forward propagate. And before going on to that, you need to like keep this thing in mind that right, the weights and biases are here. So in this one, you know, all the weights are having a, sorry, all the nets are having a weight, right? So here you can see, now here we have several weights, right? So all of those weights have, sorry, nets. So all of those nets has weights. Now I have used uh, like a simple convention here. Now the neuron 1 and 5, I have given a number to all the neurons in this neural network. So this is a neural network just designed by me for a random neural network for my problem. And the weights, right? So you can see I have used this convention that the weight that connecting, the net that connecting the neuron 1 and 5, the weight of that net is known as 1,5, the weight 1,5, right? The weight 1,5. Similarly, the neuron that's connecting 1 and 6 is weight 1,6, right? And the neuron connecting 1 and 7 is weight 1,7, right? And the neuron connecting again like 2 to 9 is weight 2,9, right? 2,9. Likewise, I have given that thing, and also the biases are also right, the biases are also given the same name, b5, b6, b7, b8, 9. So b5, 6, 7, 8, 9. And also here these two are having biases, so those are like b10 and b11. And other thing is that input layer neurons are not having biases. Keep that thing in mind. Input layer neurons are not having biases. Okay, so what we did next, right? Uh, so I applied like value 28 and 80 to the neural network. So this, yeah, this is how neural networks are training, right? And what you are going to do, the values will be forward propagated. So how they are going to be forward propagated? Now the 28 value will be going from these neurons, right? This set of neurons, right? This one, this one, this one, this one, and this one, right? And also other thing is that right, so 2 is connected to this, this, and this, right? So if you take this neuron 5, right? So we know the value of this neuron, it's 28, right? So this is 28 and this is 80, right? This is 80. So those values will be forward propagated, and what's going to happen actually, now you can see that there is an output from this neuron, right? There's output from that neuron. So that value, that output is going from here and to this neuron, right? So the output is going from here, from this one line and this one, right? So this output, let's say the output is y, right? And I'm going like refer it like y. Uh, yes. uh, yeah, anyway. So yes, so the value is y5, right? Y5. Let's say the output from this neuron is y5. So y5 can be calculated like this, right? This is how we are going to calculate the y5 value, right? Y5 value, and that value is basically calculated like this. And the equation that we are going to apply here is like you know, y equal f z, right? Y equal f z, and you can remember the z is like sigma w I xi plus b, right? Sigma wi xi plus b. Now what's going to happen? So sigma wi xi plus b. Now here there are inputs coming from two neurons. You can see we have like inputs coming from two neurons. So what we are going to do, the x1, the x1 is this one, right? And this is x2, let's say. Make x1 make x2. එතකොට මොකද වෙන්නේ? මේ x1 එක එන්නේ ඔයාලට තේරෙනවා මෙන්න මේ line එක දිගේ y5 එක එන්නේ 1 to 5. So that means it should be the x1 value is going from this net, right? This red color net. So what's going to happen? This red color net, right? So what's going to happen? The x1 will be multiplied with the weight of that net. So the weight of that net is 1, 5, right? Similarly, to this neuron, another input is coming from this, the second neuron, right? So to the input number 5, so the neuron number 5, we have like another input coming from neuron 2. So that value is x2, and that value is coming from this net, and that net is like the net connecting the neuron 2 and 5, the neuron 2 and 5. So that's called, so that's what happened. The x2 should be multiplied with the net, the corresponding weight, right? So corresponding weight is like 2 to 5. That means w2 to 5, right? W2 to 5, and that will be multiplied with x2. You can see it here, right? So you can see it here, right? Understood? Here you can see it, right? And later what we are going to do, like we are going to apply, we are going to add the bias of that neuron b5, right? Similarly, y6 will be calculated, the output of the 6th neuron, the 7th neuron, 8th neuron, 9th neuron, right? So its values will be calculated, right? Then what we can do, now we are in this actually now we are in this level, right? So we are in this level. Now what will happen? In this level, we have calculated like y5, y6, y7, and y8 and y9, right? And like in order to calculate those values, we need to apply those values into a function called this f function, and this f function is known as the activation function, right? So this f function is known as the activation function. So we are going to apply those values, whatever the values coming from here, to the activation function. Then these y5, y6, y7, y8, y9 will be calculated, right? Then what's going to happen? Those values will be again passed to the preceding layer, right? The other layer. That means here we have like only one hidden layer. So the other layer, the next layer will be the output layer, right? So similarly, those the Wi-Fi will go from this net and to this neuron, and Y6 will be going from this line to this neuron. Likewise, we have again the Y outputs are going from these nets, right? So what we can do similarly, like we have to multiply the value coming from this neuron with the corresponding weight, right? So that's what we have done here, right? And finally, we have to add the bias as well, right? Here also corresponding weights, and we have added the bias as well, right? Like I corrected, but I forgot this one. So this should be like 7, 11, 8, 11, 9, 11, right? That's a mistake I had in the right. Okay, so that's what happened, right? And yes, so now we got like values for y10 and y11. So we say these are the values predicted by the neural network, the predicted values of the neural network, right? So we say y predicted, y10 and y11, right? So it's like as I mentioned, when you are doing a past paper, right? So we got the first question, right? So we got the first question, and without looking at the answers, we wrote the answer for that question. It's like this. So I predicted the predicted y value. Predict කරපු y value එක. දැන් අපි exam එකටත් එක කරන්නේ. මොකද්ද? අපි question එකක් ආවම ඒ question එකට අදාළ pass paper එකක් කරනවා නම් question එකට අදාළ answer එක ලියලා තමයි අපි පස්සේ බලන්නේ මේ question එකට ලියපු answer එක හරිද කියලා. Similarly මෙතනත් අපි ඒකම තමයි කළේ. So but we know like the values, the actual values of y10 and y11, the values should come to y11 and y10. y10ටයි y11ටයි එන්න ඕනේ ඇත්ත values අපි දන්නවා. මොකද ඇත්ත values දන්නවා කියලා කියන්නේ අපි පොඩ්ඩක් ආපහු ගිහිල්ලා බැලුවොත් right අපි මේකනේ apply කළේ. එතකොට ඒ apply කරපු දවසේ ඇත්තටම මොකද උනේ කියලා අපි දන්නවා. ඒ කියන්නේ මේ label එක අපි දන්නවා. So the label is like 0, that means no rain. එදා වැහැලා නැහැ. එහෙනම් අපි දන්නවා මෙතන එන්න ඕනේ value එකක් මොකක්ද කියලා. දැන් ආපු එක මේක. Right? y11 and right? And like we need to like we know the actual value, right? We need the actual value. Now these weights and biases I mentioned, like these are variables and those are real numbers, right? So at the initial, as I mentioned last time, at the initialization of the neural network, these values will be uh, these values will be assigned to random values. ඒ කියන්නේ මෙතන තියෙන මේ weights, මෙතන weights ඔක්කොම තියනවා නේද? කීයක් තියනවද? weights 20යි නේද? 5 වරක් 2යි 5 වරක් 2යි 20යි. ඊළඟට biases තියෙනවා මෙතන ඔක්කොම 7ක්. එතකොට මෙතන ඔක්කොම trainable, sorry, මෙතන 5ක්, ඔව් 7ක් තියෙනවා. එතකොට මෙතන ඔක්කොම trainable parameters තියෙනවා 27ක්, right? 27 trainable parameters. So the values of those weights and biases will be initialized randomly, as I mentioned, right, last time. But yes, so I mean, definitely there will be some values to y10 and y11, right? But the thing is, now we know the actual values, right? So the actual value will be 1, 0. So let's assume that the predicted values are like 0.2 and 0.8, the predicted values, right? Now these are the values that predicted by the neural network by applying to these equation, and somehow at the end it calculated y10 and y11. So the y10 and y11 values are like 0.2 and 0.8, right? So the actual, right? So the y actual and the y actual will be right. So the y actual will be 1 and 0, since we know this is coming from the data set, right? So this thing is coming from the data set, right? So this thing is coming from the data set, and this is from the neural network predicted, right? This is predicted from the neural network, right? So you can see that yes. So what we can do then, what we can do that what we are going to do then, actually now we are going to compare this one and this one. මේක හරියට අපි question paper එක ලිව්වහම මේක තමයි එන්න ඕනේ actual answer එක. අපි question එක බලන්න නැතුව අපි ලිව්ව answer එක තමයි මේක. right? අන්න ඒ වගේ බොහොම සරල දෙයක්. දැන් අපි දන්නවා එහෙනම් like we need to somehow like we did a question, so that's kind of a training. Now what we need to do, we need to like improve, right? We need to improve ourselves, right? We need to improve ourselves. So in order to improve, what we have to do is we have to now the answers that predicted by the neural network are not matching with the actual answers, are not, or not even close, right? The values will be like 1 and 0. Now it's a no rain day, right? So rain or no rain day, so 1 and 0. So what happened? These values should be like like closer to the actual value. දැන් අපි answer එකක් ලිව්වහම ඒක පොතේ තියෙන අර අවසානයේ තියෙන actual answer එකත් එක්ක සමාන වෙන්න ඕන. නැත්නම් ලං වෙන්නවත් ඕනේ අඩුම ගන්න. ඒක තමයි අපි හරියට prediction එක නැත්නම් අපි හරියට answer එකක් ලිව්වා කියලා හිතන්නේ. So what we need to do, like we need to somehow get the predicted value to the actual value, closer to the actual value, right? So in order to get it closer, what we can do, right? We need to change the y10 and y11, the predicted y10 and predicted y11, right? So in order to change the predicted y11 and y10, what we need to do? What we need to do, right? So in order to change y10 and y11, what we should do? Last time we discussed. Yes? We need to change y10 and y11, and somehow we have to like make them closer to the y actual. So what we are going to do? Yes? Yes, change the weights and biases. So that's the only method of doing this. Now, we know, right? We know that y predicted and y predicted, y10 and y11 are depends on weights, biases, and also x. So what's the reason, right? So we know that y is a function of weights, biases, and the inputs. So is it true? Yes, it is. Why? Now y10, you can see it's like weights are there, y's are there, right? And the biases are there. And you can see this y5, y6, again, they are depending on x1, x2, and other weights and biases. So definitely we can say the y predicted is a function of weights, biases, and inputs, right? So what we need to do now, we need to somehow change the value of y predicted. So changing the value of y predicted is depending on the dependencies, right? So the dependencies are the weights, biases, and x's, right? So can we change x's? No, we can't change x. So x is like the temperature and humidity. දැන් එදා වැස්සද නැද්ද කියන එක නැත්නම් එදා temperature දැන් අවුරුදු 10කට කලින් දවසක temperature එකයි humidity අපිට වෙනස් කරන්න බෑ. So those are like right, historical data. So you can't change those things, right? So what's the only thing that we could do is to change the weights and biases. So we have to adjust the weights and biases, right? So what we are going to do, that's the right. So that's the basic thing to do. And yeah. So how did we right? So we are going to calculate the error in order to do this, right? So we are going to calculate the error, and that error will be basically the difference between the y actual value and the y predicted value, the difference, right? And we are going to get the error, and we need to minimize this error. That minimizing the error is like if you can make the error 0, that means y actual is equals to y predicted. Similarly, if we need to like make we need to make y predicted closer to the y actual. That means what we have to do, we have to that's the method of minimizing the error, right? So in order to minimize the error, we need to now erase this, basically y actual minus y predicted. So then in order to change the error, we can't change the y actual. අපිට අපේ marks අඩු වෙනවා කියලා exam එක අපිට marking scheme එකේ තියෙන answers වෙනස් කරන්න පුළුවන් අපිට දෙන answers වලට. No. එහෙනම් අපි මොකක්ද කරන්නේ? We are going to change our answers according to the marking scheme answers, right? So that's how we are going to adjust the weights and biases, right? So we have to adjust weights and biases. Now, adjusting weights and biases, like in this case, we have 27 trainable parameters. So we have like adjust each and every. And also I mentioned last time that adjusting the weights and biases, like we have to do it independently and individually, right? That means like each weight are having different and individual and independent effect towards the error, right? So we have to adjust all the weights and biases, but we have to do it independently and individually, right, as I mentioned. And so we have to adjust the weights and biases, right? So in order to do this, we discuss about the gradient descent algorithm. So gradient descent algorithm is the yeah, we have to optimize the loss. That means we have to find the optimal values of weights and biases which gives the minimum loss, right? So that's what you call the loss optimization. So in order to optimize the loss, what we have to do, we have to like minimize the error, and at the end we are going to reach the optimal loss, right? The optimal loss, right? So in order to do this, we are going to optimize the loss, and we need to use the optimizer, right? So that optimizer, the fundamental type optimizer is the gradient descent algorithm, right? So I have a small video from 1 3 blue brown, sorry, 1 brown 3 blue YouTube channel, right? So I will show it here, right? So this will recall the what we discussed under gradient descent algorithm last time, right? Okay. Okay. Can you hear the sound of the video? Can you hear the sound of the video? Okay. Right. Okay. Now.
All of the neurons in the previous layer, and the weights in the weighted sum defining its activation are kind of like the strengths of those connections.
Now can you hear? Okay. Right. So.
The bias is some indication of whether that
Yeah.
neuron.
So we'll start from the beginning, right? Okay.
Remember, conceptually, we're thinking of each neuron as being connected to all of the neurons in the previous layer, and the weights in the weighted sum defining its activation are kind of like the strengths of those connections. The bias is some indication of whether that neuron tends to be active or inactive.
Right. So there's like an important point mentioned. The weights are like giving weight to the net, right? Whether that net, the like we say the yeah, the what you, I can't remember the, like, but the, yeah, the weight is like the power or the what you call, let me see.
And to start things, remember, conceptually, we're thinking of each neuron as being connected to all of the neurons in the previous layer, and the weights in the weighted sum defining its activation are kind of like the strengths.
Yeah,
of
the
those
strength, right? The strength.
The bias is some indication of whether that neuron tends to be active or inactive. And to start things off, we're just going to initialize all of those weights and biases totally randomly. Needless to say, this network is going to perform pretty horribly on a given training example, since it's just doing something random. For example, you feed in this image of a 3, and the output layer, it just looks like a mess. So what you do is you define a cost function, a way of telling the computer, no, bad computer, that output should have activations which are 0 for most neurons, but 1 for this neuron. What you gave me is utter trash. To say that a little more mathematically, what you do is add up the squares of the differences between each of those trash output activations and the value that you want them.
Right, so the error, calculating the error, the value given and the actual.
To have. And this is what we'll call the cost of a single training example. Notice, this sum is small when the network confidently classifies the image correctly, but it's large when the network seems like it doesn't really know what it's doing. So then what you do is consider the average cost over all of the tens of thousands of training examples at your disposal. This average cost is our measure for how lousy the network is and how bad the computer should feel. And that's a complicated thing. Remember how the network itself was basically a function, one that takes in 784 numbers as inputs, the pixel values, and spits out 10 numbers as its output. And in a sense, it's parameterized by all these weights and biases. Well, the cost function is a layer of complexity on top of that. It takes as its input those 13,000 or so weights and biases, and it spits out a single number describing how bad those weights and biases are. And the way it's defined depends on the network's behavior over all the tens of thousands of pieces of training data. That's a lot to think about. But just telling the computer what a crappy job it's doing isn't very helpful. You want to tell it how to change those weights and biases so that it gets better. To make it easier, rather than struggling to imagine a function with 13,000 inputs, just imagine a simple function that has one number as an input and one number as an output. How do you find an input that minimizes the value of this function? Calculus students will know that you can sometimes figure out that minimum explicitly, but that's not always feasible for really complicated functions. Certainly not in the 13,000 input version of this situation for our crazy complicated neural network cost function. A more flexible tactic is to start at any old input and figure out which direction you should step to make that output lower. Specifically, if you can figure out the slope of the function where you are, then shift to the left if that slope is positive, and shift the input to the right if that slope is negative. If you do this repeatedly, at each point checking the new slope and taking the appropriate step, you're going to approach some local minimum of the function. And the image you might have in mind here is a ball rolling down a hill. And notice, even for this really simplified single input function, there are many possible valleys that you might land in, depending on which random input you start at. And there's no guarantee that the local minimum you land in is going to be the smallest possible value of the cost function. That's going to carry over to our neural network case as well. And I also want you to note it.
Okay, right. Yes, so I will like we discussed about this idea last time, the gradient descent algorithm, right? So I will go through that again, and we will move on to the activation functions, loss functions, and then we have to like discuss about the backpropagation algorithm, right? Okay, so I will yeah. Yes, so I will start from here. So we know that this thing, right? So what we need, we are going to like, when we are going to train a neural network, we are going to first apply the features, and the neural network is going to propagate for speed for like forward propagate, and the output values will be calculated like this, right? Like this, applying sigma wx plus b, right? Simply. And after that, it's going to compare the predicted value will be with the actual value, right? The predicted value with the actual value. ඉස්සලාම් neural network එකට දාන input එකෙන් output එක neural network එක calculate කරනවා sigma wx plus b කියන equation එක දාලා ඊට පස්සේ actual value එකත් එක්ක මේ දෙක compare කරලා බලලා අපි ගන්නවා error එක, right? error එක. මේ error එක ගත්තට පස්සේ අපි මොකද කරන්නේ? මේ error එකත් එක්ක අපි මේ error එක අඩු කරගන්න ඕනේ. ඊළඟ පාර මේ එන error එක අඩු කරගන්න ඕනේ, right? So we need to minimize this error, right? So we know that error is between the difference between the actual and the predicted values, right? Error between the actual and predicted value. So we are going to calculate the error, right? And we are going to do something to minimize this error. So we have like minimized the error. So in order to minimize the error, we need to change the error, right? In order to change the error, we need to change y actual or y predicted or both. But we can't change y actual since it's historical data. So we can change y predicted, and we know y predicted is a function of weights and biases. So automatically the error will become a function of weights and biases. මොකද y predicted තමයි error එක වෙනස් කරන්න තියෙන එකම විදිය. එහෙනම් y predicted නම් error එක වෙනස් කරන්න එකම තියෙන විදිහ y predicted වෙනස් කරන්න තියෙන්නේ weights and biases මත තමයි dependent. එහෙනම් weights and biases වෙනස් කරලා තමයි error එක වෙනස් කරන්නත් වෙන්නේ. එහෙනම් error එක කියන්නේ weights and biases මත dependent function එකක්. Right? And we have like the optimal target will be, the final target will be, we have to calculate the set of weights and biases. අපිට weights and biases set එකක් calculate කරන්න වෙනවා මේ neural network එකේ minimum loss එක දෙන්න. Right? Minimum loss එක දෙන්න. දැන් ඒක තමයි අපි කරන්න යන්නේ loss optimization. So in order to optimize the loss, we need to use the optimizer. So that optimizer, the fundamental type of optimizer in a neural networks is gradient descent algorithm. So we are going to discuss about gradient descent algorithm, but in nowadays we are not using gradient descent. We have like more advanced optimizers, but the fundamental type we have to learn, and all the other optimizers are like adapted version of the gradient descent optimizer. Okay, right? So the gradient descent optimizer quickly. Right. Okay. Right. So what I discussed last time, that let's say we have, right? Let's say that we have, yeah. Right. So we are going to, now this is the error, right? This is the error. And I'm going to plot a graph between the error and the weight 1. Now, weight 1 in the sense one weight of your neural network, one weight, just a one weight of your neural network, right? And so පළවෙනි පාර මොකද වෙන්නේ? අපි අර input layer එකට value එකක් දානවා, right? Right? x1 මෙච්චරයි, x2 මෙච්චරයි. ඊට පස්සේ අපි y1 y2 calculate කරලා ගන්නවා. Yes. Okay, anyway, right? Yes, so right. Okay, right? So we are going to apply a set of x1 and x2 into the neural network, and set of yn and y2 will be calculated, right? And what we can do, then we can get the error, right? We can get the error then, right? Error between y actual and y predicted, right? Y actual and y predicted. So what we can do now, okay, let's say now we are dealing with this one, right? So this, let's say this is the weight one, right? This is the weight one of the neural network, right? And we know like the y1 and y2 and the y actual one, y predicted, we know. Now let's say that we know the value of, let's assume that we know the value of w1 0.5, and we know the error coming from here is like, let's say 10, right? So what we can do, we can mark this thing, right, somewhere here, right? Okay, so this is, I mean, I just marked the point with the error and the W1. I'm considering only the W1. මම එක weight එකක් ගැන විතරයි මේ වෙලාවේ කතා කරන්නේ. අනිත් weights වලටවත් මේ වැඩිම තමයි වෙන්නේ, right? So now we have an error of 10, right? So our always our දැන් මේ neural network එක train වෙන හැම වෙලාවෙම අපේ target එක මොකද්ද? Right? What's the the prime objective of training this neural network, right? මොකක්ද හැම වෙලෙම අපිට තියෙන target එක මොනවා කරන්න? Yes. neural network එකක් train වෙද්දී අපි questions වල අපි ප්‍රශ්න පත්‍ර වලට උත්තර දෙන්න අපේ target එක වෙන්නේ මොකක්ද? Right? So what's our target? Yes. Minimizing the අපිට minimize අපේ error එක අඩු කරගන්න නැත්නම් අපේ ලකුණු වැඩි කරගන්න තමයි අපි try කරන්නේ හැම වෙලෙම to minimize error. So we need to minimize the error always, right? Reduce the error. Yes. So what we need to do, we need we have 10 value and we need to minimize this. අපිට මේක අඩු කරගන්න ඕනේ. In order to do that, we need to adjust the weights one period කියනවා. Weights and biases adjust කරනවා. We need to adjust the weights and biases. So we are going to adjust one weight here. We are only considering weight 1. Okay. Now, in order to minimize the error, do I need to increase this weight or decrease this weight? Yes. Do I need to increase this one or decrease this one? Yes. Okay. Yes. Decrease. I mean, do I need to decrease the weight one or increase the weight one? So we say decrease. No, we can't say exactly. Right? We can't exactly say. අපිට එකපාරම මේක කියන්න බෑ. ඇයි? සමහර වෙලාවට අපි හිතන්නකො මෙහෙම කරා කියලා හරි. weight එක පොඩ්ඩක් වැඩි කරනවා. මොකද වෙන්නේ? සමහර විට error උඩට යන්න පුළුවන්. Right? We can't say exactly. Yes, we can't say. Right? Right? We can't exactly say what to do. Right? සමහරට එහෙනම් කනාපාරක් කරන්නත් බෑ අපි, right? So we can't predict it. අඩු කළාම සමහර විට error එක අඩු වෙන්න පුළුවන්. දැන් මෙතනට weight එක අපි අඩු කළොත් එහෙම right? හරි. මෙන්න මෙතනට යන්න පුළුවන්, but we can't say it. Right? Right? So what we need to do, right? We can change and see. No, we can't do that. I mean, we can change and see. No, we can't do that. Things if you are changing the weight, so then we have apply the data set again and calculate the weight. No, that's not how it's working, right? Here what's going to happen, it's going to calculate the gradient. The gradient. Right? The gradient. Right? So the gradient is actually DABA E over DABA W1. This is called the gradient. Last time I discussed this. So this is called the gradient. Right? We are going to calculate the gradient. And this is actually given by, right? This is given by backpropagation algorithm. Backpropagation algorithm. This value is given by the backpropagation algorithm. We will discuss that thing also later, right? Backpropagation algorithm එකෙන් අපිට ගෙනල්ලා දෙනවා මේ වෙලාවේ තියෙන gradient එක. මේ point එකේ gradient එක. Right? The gradient. දැන් මට කියන්න හරි මේ gradient එක තියෙන ඔන්න ඔය විදිහට. අපි මේකට කියනවා මොකද්ද? right? මේකට අපි කියනවා දන්නා gradient එක නේද? දැන් ඔහොම සරලයිනේ. අපි right? මෙහෙම එකක් තිබ්බොත් එහෙම y and x. අපි මේකට කියන්නේ මොකද්ද? මෙන්න මේකට අපි කියනවා මොකද්ද? මේක අපි θ කිව්වොත් tan θ කියලා අපි කියනවා. නැත්නම් gradient කියලා කියනවා. ඔකට අපි කියන්න පුළුවන් dy over dx කියලා. right? නැත්නම් මට මෙහෙම කියන්න පුළුවන්. අපි yx කියලා graph එකක් තිබ්බොත් එහෙම මෙන්න මේ point එකේ gradient එක right මෙන්න මේ point එකේ තියෙන gradient එක මට කියන්න පුළුවන් dy over dx right dy over dx මේ point එකේ gradient එක නම් මේ වෙලාවේ අපි ගන්න ඕනේ මම හිතුවත් එහෙම මේ වෙලාවේ value එක x1 කියලා අපි කියනවා x1 කියලා මෙතන. ඒතර x1 මේ වෙලාවේ තමයි අපි මේ ගන්න gradient එක. Right? So this is called the gradient. And now we are going to calculate the gradient here. Right? And that gradient will be given by the backpropagation algorithm. I will discuss about that thing later, the backpropagation algorithm. Now, okay, my point, if you have the gradient like this, right? If you have the gradient like this, are you going to increase the weight or decrease the weight? Increase the weight. What's the reason of? All right, we have answer. Increase the weight. Can you give me why? I mean, what's the reason behind? I increase කරන්න කියලා කියන්නේ. Increase කරන්න ඕන කියලා කියන. ඇයි increase කරන්න කියලා කියන්නේ? මොකක්ද හේතුව? Yes, we had some answers. Error will reduce by doing it. Gradient is minus. Yes, yes, good. Then, මට කියන්න බලන්න. So can you see now, in this point, we say the gradient is, like, you can see the gradient is negative, right? So that's something you should know by your O-level maths, right? So this gradient is positive, and this gradient is considered to be negative, right? So you know that thing, right? So here it's a negative gradient. So in the negative gradient, what it says? Now can you see this? I mean, this curve is coming. I mean, right? Coming down, right? Can you see? This is coming down, right? It's coming down. That means the gradient is negative. It means that means your curve or your graph is coming down. I mean, here what's happened? What's going to happen? So the gradient is to be said to be positive, right? So that means your graph is going up, right? Your graph is going up. Understood? Right? So we have simple, this is a simple thing, right? So we have a algorithm called the gradient descent algorithm. In gradient descent algorithm, it says the weight adjustment, the new weight, right? So the gradient descent algorithm is going to give us a way to calculate the new weight, right? So it says the weight, the new weight is equals to the old weight minus, right? Old weight minus delta weight. That means it says new weight is equals to the old weight minus a small portion of the old weight. Gradient descent algorithm. They can gradient descent algorithm. Right? Gradient descent algorithm එක කියන්නේ අලුත් weight එක සමානයි පරණ weight එකෙන් ඒ weight එකෙන් පොඩි කෑල්ලක් අඩු කළාම එන value එකට. and මේ පොඩි කෑල්ලට අපි කියනවා මෙන්න මේක කියලා. Da by E divided by da by W. Da by. daba partial derivative last week discuss kala, right? Partial derivative. Now here the point that yes, now here my point is okay. Okay, now here අපි මේක තමයි apply කරන්නේ. දැන් the back propagation algorithm is going to give us the gradient. This portion will be given, da by e or da by w will be given, and we are going to apply these equations to find the new value of the weight, right? So you can see now this is the gradient, and this is something called the eta is called the learning rate, right? So this is called the learning rate, and we will discuss that thing later, the learning rate. Now here what's going to happen? Now can you see if the gradient is negative, what's going to happen? If the gradient is negative, weight will be equals to weight minus eta da bar e over da bar w, right? So if this portion is negative, right? If this portion is negative, what's going to happen? Weight minus into minus, it will be plus, right? තේරෙනවද? මෙතන දැන් මේක නෙගටිව් වුණොත් මේක නෙගටිව් වැලියු එකක් වුණොත් මොකද වෙන්නේ? මෙතන ඍණ එකක් තියෙනවා, මේ ඍණ එකත් එක්ක ගුණ වෙලා ධන වැලියු එකක් වෙන්නේ. එහෙනම් මේක හරියට නිකන් මොකක් වගේද? weight එක weight plus some value, right? Similarly අනිත් වෙලාවට මොකද වෙන්නේ? right? අනිත් වෙලාවට right? මේ වෙලාවට මොකද වෙන්නේ? right? මේ වෙලාවට මොකද වෙන්නේ? එතකොට gradient එක positive නම් මොකද වෙන්නේ? හා? gradient එක positive වෙලා මොකද? මේක positive වුණොත් මොකද වෙන්නේ? right? ඒ වෙලාවට එහෙනම් අපිට කියන්න පුළුවන් මොකද්ද? weight එක weight plus sorry weight minus පැහැදිලිද? right? Understood, right? Okay, now can you see in this equation we have, right? Okay, so here you can see two things, that the gradient descent algorithm is the algorithm that going to adjust the weight. Now this is for only one weight, and this is done repeatedly for each and every weights and bias or trainable parameters in your neural network, right? So this is one instance. This is how it's going to do it for one weight, right? This is how it's going to do it for one weight. Now my point, the gradient, so this is the gradient, you can see the gradient. So this gradient is going to decide two things, right? This gradient is going to decide two things, right? The number one thing is, right, whether we are going to increase or decrease the weight, right? Whether it's going to increase or decrease the weight. The other thing is the magnitude. The magnitude. The magnitude. The weight එක අඩුද කරන්නේ වැඩිද කරන්නේ කියලා decide කරන්නේ gradient එක. මෙන්න මේ gradient value එක, right? සහ ඒ අඩු කරන ප්‍රමාණය කොච්චර ලොකුද නැත්නම් ඒ වැඩි කරන ප්‍රමාණය කොච්චර ලොකුද පොඩිද කියලා තීරණය කරන්නේ ඒත් ඔය gradient එකමයි, right? Understood? හරි. දැන් මේ බලන්න හරි. අපි හිතමුකෝ gradient එක positive කියලා මෙහෙම gradient එකක් කියලා මොකද කරන්නේ? මෙයා කියන weight එකෙන් යම් කිසි ප්‍රමාණයක් අඩු කරන්න කියලා, right? So it says like, right? So you can see now here, if the gradient is negative, like we are asked to add the value, right? Add the value, add a small value. That value is learning rate. So this learning rate is a like a value between, I mean, it is a value, it can be defined by us, ඊට කියන්නේ අපිට define කරන්න පුළුවන් value එකක් constant එකක්. ඒක ඕන වෙලාවක වෙනස් වෙන්න පුළුවන් constant එකක්. variable එකක්. හැබැයි අපි හිතමු දැනට constant එකක් කියලා. ඊට පස්සේ the gradient, right? okay දැන් මෙහෙම තිබ්බහම negative gradient එකක් හින්දා අපිට value එක එකතු කරන්න කියලා කියන්නේ. එහෙනම් අපි right 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 okay අපි දැන්ට assume කරමු right I'm going to assume like okay the DABA E over DABA W1 value given by the backpropagation algorithm is equals to like 0.5, right? And right 0.5 and assume the learning rate is 0.1, right? 0.1. Now can you give me the now new weight, right? So the new weight will be the old weight. What's the old weight? Huh? Zero. Uh, you might get confused with this, like okay, let's say 0.7, right? Okay, so the old weight is what? The old weight is 0.5 minus learning rate is 0.1 into 0.7. So the new weight will be, right? So the new weight will be 0. What? 0. Yes, 0.43, right? 0.43. It will be 0.43. Yeah, so it will be 0.43. You can see, right? 0.43. So that means what? It asks us to, right? It asks us to change it to, sorry. Right? It should be plus, right? Yeah, sorry, this should be like negative, huh? Negative gradient acne, so it should be negative. So that means we have to add it here. All right, so it's 0.57, right? 0.57. So what we are going to do, we are going to add it here, right? 0.57. So then we are going to calculate the error. So the weight adjustment is done, and we are going to apply the new data, the next row. ඊළඟට අපි next row එක apply කරනවා. weight එක adjust කළා. ඊළඟට next row එක අපි දානවා. data set එක ඊළඟ row එක දානවා. ඊළඟ row දැම්මා මේ value එක තියෙන වෙලාවට එනවා මෙතනට value එක. Right? Understood. Right? ඊට පස්සේ මොකද කරන්නේ? Right? ආපහු අපි මෙතන gradient එක calculate කරනවා. මෙහෙමද? The gradient එක, we are going to like take the gradient from the backpropagation algorithm, right? So my point I want to highlight that okay, what's going to happen if this gradient value is larger? දැන් මේ gradient එක තව පොඩ්ඩක් ලොකු වුණා නම් මොකද වෙන්නේ? ඒ කියන්නේ මෙන්න මෙහෙම ටිකක්. sorry. මේ gradient එකක් ටිකක් ලොකු වුණා නම් මොකද වෙන්නේ? මෙහෙම ටිකක් ලොකු gradient එකක් නම් මොකද වෙන්නේ? හරි ඔව් මේකයි gradient එක ලොකු වුණොත් මොකද වෙන්නේ, right? So when like I mean if the gradient is larger than larger than the earlier case, gradient එක කලින් එකට වඩා වැඩි නම් මොකද වෙන්නේ? ඒ කියන්නේ similarly අපි හිතමුකෝ මේක වෙනුවට right minus 0.1. So what's going to happen now? So then this should be right plus 0.1 into 1 and this will be 0.6, right? This should be 0.6. Understood? Now in that case what will happen? This will be like somewhere here, right? That means the new value will be, I don't know whether the error is going to decrease than this or not, but it will be somewhere here now. error එක අඩු වෙයිද, يعني error එක විතර අඩු වෙයිද වැඩි වෙයිද කියලා කියන්න බෑ. හැබැයි අපි හිතමු පොඩ්ඩක් weight එක මෙහාට move වෙනවා ගොඩක්. Right? Understood? Right? So that means magnitude decide two things, that whether it's going to be a increment or in the weight or a decrement in the weight or the magnitude of the weight adjustment, right? So the gradient is going to decide both those two, right? Decide both of those two. Understood? Okay, now yes, so with that and what I want to highlight then, right? Okay, now okay, right? Okay, right? So we are going to get the gradient like this. From the back propagation algorithm, it's going to give a gradient like this, right? So we know definitely the weight should be increased, right? Okay, so now the next point is somewhere here. Okay, right? Okay, right? Okay, then again the gradient descent algorithm is going to give us a point like this. I'm just assuming, right? And the gradient is like this, right? Okay, now then our weight adjustment is done, right? Okay, now I'm going to do the next weight adjustment. Okay, right? Now the backpropagation algorithm is going to give a gradient like this. That means what? Yes, that means what? Now the gradient becomes, yes, positive. That means what? We have like do what? We have to decrease the weight now. You know, the right, negative, negative, negative. This becomes positive. That means what we have to do now? The gradient becomes, suddenly the gradient becomes positive. That means what? That we have to not increase the weight, but we have to decrease the weight now, right? Yes, that means the minimum error is passed actually, right? So what we have to do now, this point, right? So we need to like come back here, right? I mean, we have to decrease the error, right? Give me a minute, give me a second. Okay. Yes. Right. So then it becomes like that says, okay, so the direction should be changed. Then api giyapu patta එහෙනම් මාරු වෙන්න ඕනේ දැන්. Right. So we need to like change the direction. That means we have to come back. Right. We need to come back. Right. So we need to come back again to this one. That means we know, right? We know this. Uh, the error, right? So the error, the weight adjustment will be right like this, right? Understood, right? Yes. So now when it's become positive, that means we have to reduce them, right? So now that means now it's like this, right? The graph should be somewhere like this, something like this, right? Something like this. Now, I mean, we have to change these points, right? Okay, now it should be something like this. That means the minimum point that we have passed it. So somehow we have to find it. Now, can you see that the gradient descent algorithm is automatically going to do that, right? මේ පැත්තේ තියෙද්දි මොකද වෙන්නේ? අඩු කරගෙන අඩු කරගෙන අඩු කරගෙන එනවා, right? මේ පැත්තට පැනපු ගමන් ආපහු මේ පැත්තට අඩු කරනවා, right? So somehow you are going to end up somewhere here, right? Going to end up somewhere here, right? Yes, so that's what actually happens, right? Yes. Now, what's going to happen here, as I mentioned, it's going to like increase the weight and somehow decrease the weight, right? If the minimum point is passed, right? If the minimum point is passed, it's going to decrease this error, right? Sorry, decrease the weight value, right? Decrease the weight value. So that's what's going to happen actually here. Now, can you see the thing is here now the gradient becomes, I mean, gradient negative, but the gradient becomes decreased, right? The magnitude of the gradient. You know, the gradient එක මේ පැත්තේ negative, හැබැයි gradient එක පොඩ පොඩ අඩු වෙනවා, right? So what's going to happen? I mean, like මේ වගේ point වල වෙන්නේ මොකද? Gradient එක ගොඩක් ලොකු. එතකොට ලොකු steps වලින් weight එක අඩු කරනවා, right? So here the gradient is large, right? The magnitude of the gradient is large. That means the weight adjustment will be rapid weight adjustment. I mean, like large magnitude weight adjustments, right? When it's common, I mean, when it's become like the gradient, now you can see the gradient is, the magnitude of the gradient is also decreasing here. That means the weight adjustment is becoming lower, lower, and lower, right? It's like I mean, we are coming from uh, top of a hill to the bottom, right? කන්දක උඩ ඉඳන් බිමට එනවා වගේ අයියේ. මුල් ටිකේ ටිකක් හයියෙන් හයියෙන් ඇවිල්ලා මොකද වෙන්නේ? අර bottom එක reach කරද්දී අපි නිකන් පොඩ්ඩක් නේද? slow කරගෙන ඇවිල්ලා නවතිනවා, right? So similarly here. Now what's going to happen? Right, so let's say that we have a thing like this, right? So you can see, right? So rapid weight changes here, right? Right? But coming to here, small weight changes, right? Right? Small weight changes. Understood? So that's what actually going to happen, right? So somehow this, so it's not going to be a matter if you pass the minimum point. අපි minimum point එක pass කරාට ප්‍රශ්නයක් වෙන්නේ නැහැ, right? මෙහාට පැනපු ගමන් gradient එක positive වෙනවා. The gradient becomes positive. Then again we are coming back here. We are reducing the weight and somehow we have to come to this point, right? So can you see now this is going to end when, right? When this becomes 0, right? Can you see now the weight adjustment will be 0. That means the old weight will be new weight when this portion will become 0. So that means we have like make the gradient 0. So the gradient 0 point, right? So the gradient 0 point is here, right? So you can see the gradient point, gradient 0, right? The value of the gradient 0 here. Understood, right? Right? Okay, so that's how the gradient descent algorithm works actually, right? So කොතන හිටියත් කමක් නැහැ, right? So no matter where the error is, somehow using this gradient descent algorithm, it's going to come to the minimum possible loss or the minimum possible error, right? මොකද gradient එක වැඩි වුණොත් error එක වැඩි වෙනොත් slope එක වැඩි නම් slope එක negative නම් error එක අඩු කරගෙන එනවා. slope එක positive වුණ ගමන් weight එක අනිත් පැත්තට කියන්නේ weight එක අඩු කරනවා. gradient එක negative නම් weight එක වැඩි කරනවා. gradient එක positive වුණ ගමන් weight එක අඩු කරනවා, right? So when the gradient is negative, it's going to increase the weight, and when the gradient is positive, it's going to decrease the weight. Somehow it's going to end up at the minimum loss, right? The minimum loss. Okay, so that's the theory, right? So that's what the theory says, but what happens, right? What happens here? මේ වගේක් වුණොත් මොකද වෙන්නේ? theory එකේ කියන්නේ ඒ වගේ දෙයක්, right? But that's the ideal case. The ideal case. ඒ තමයි ideal case එක. හැබැයි මෙහෙම වුණොත් මොකද වෙන්නේ? Right? What happens here? Okay, so this is your error. Yes. So what's going to happen here? Yes, in this kind of a case, right? In this kind of a case, what's going to happen? Yes. So if you are like, okay, from here, what's going to happen? Okay, gradient is negative, negative, negative. That means increase the weight here. Okay, positive. Okay, so decrease the weight, and you are going to somehow end up here. Okay, now my question is this the right? Is this the global minimum, right? The global minimum. Is it a global minimum error? Is this the global minimum error? Huh? Is this the global minimum error? Yes. Right? No, right? It's not the global minimum error. So what we can do, I mean, so that means we have like somehow we have ended up in a point where the error is minimal, but that error is not the global minimum. That's a local minimum. Local minimum in the sense, right? So that's a error in a, right? So that's the error in a local area, right? The minimum area එකේ error එක මෙතන, so we can say the error is low here, the minimum error, right? This is the minimum error here. Understood? But that's not the global minimum, right? So in this case, right, so it's not going to work. You can see the theory that we built, it's not going to work. So we have something called stochastic gradient descent. Right? The stochastic gradient descent algorithm. The stochastic, or we say like the SGD algorithm, not the gradient descent, but the stochastic gradient descent, SDG, right? So what the stochastic gradient descent algorithm is going to do, it's like I will discuss about under the batch training as well. But what it's going to do, it's not going to do it like this, right? මේ වගේ මේක කරන්නේ නෑ මෙයා, right? මොකද්ද කරන්නේ? Then okay, so here it's like we are carefully, right? So you can see we are carefully coming from a top of a hill to the bottom, right? So that's what we are going to do here. But in stochastic gradient descent, no, it's not like that. It's not like a careful man. It's like a drunken person, right? It's like a drunken man, right? right? Drunken man කෙනෙක් වගේ තමයි stochastic gradient. So in stochastic gradient descent, what it's going to do, like it's going to go from larger steps, right? Larger steps. Now let's say this is the initial weight, right? So it's going to like increase the weight somewhere here. Let me redraw this, right? Okay, let's start from here, right? So what happens, like if we are like carefully coming from like this, and this, we are going to end up here, right? But it's not like, it's not going to do it like this. It's going to, if it's going to start from here, it's going to do large weight adjustments. Large weight adjustment like this and this, right? So somehow it's going to do large weight adjustment, not like small careful weight adjustment. So what's going to happen actually, right? In theory it says like I mean like a drunken man, right? So if like a careful man coming from top, from a hill to bottom, right? So it's kind of carefully coming to the bottom. But if a drunken man is there, right? So what's going to happen, right? So it's not like controlled, but somehow he will like somehow end at the bottom of the hill, right? So that's what the theory says, right? The stochastic gradient descent, I will discuss that thing later, right? But keep that thing in mind. The error is not always, the error function is not always like this, right? Not like this, not a perfect shape like this. It can be something like this as well, right? It can be something like this as well, right? So let me show, right? Yes, that video again, the remaining part of the video.
The bias is some indication of whether that neuron tends to be active or inactive. And to start things off, we're just going to initialize all of those weights and biases totally randomly. Needless to say, this network is going to perform pretty horribly on a given training example, since it's just doing something random. For example, you feed in this image of a 3, and the output layer, it just looks like a mess. So what you do is you define a cost function, a way of telling the computer, no, bad computer, that output should have activations which are 0 for most neurons, but 1 for this neuron. What you gave me is utter trash. To say that a little more mathematically, what you do is add up the squares of the differences between each of those trash output activations and the value that you want them to have. And this is what we'll call the cost of a single training example.
Cost is the same
this
as the error.
Is small when the network confidently classifies the image correctly, but it's large when the network seems like it doesn't really know what it's doing. So then what you do is consider the average cost over all of the tens of thousands of training examples at your disposal. This average cost is our measure for how lousy the network is and how bad the computer should feel. And that's a complicated thing. Remember how the network itself was basically a function, one that takes in 784 numbers as inputs, the pixel values, and spits out 10 numbers as its output. And in a sense, it's parameterized by all these weights and biases. Well, the cost function is a layer of complexity on top of that. It takes as its input those 13,000 or so weights and biases, and it spits out a single number describing how bad those weights and biases are. And the way it's defined depends on the network's behavior over all the tens of thousands of pieces of training data. That's a lot to think about. But just telling the computer what a crappy job it's doing isn't very helpful. You want to tell it how to change those weights and biases so that it gets better. To make it easier, rather than struggling to imagine a function with 13,000 inputs, just imagine a simple function that has one number as an input and one number as an output. How do you find an input that minimizes the value of this function? Calculus students will know that you can sometimes figure out that minimum explicitly, but that's not always feasible for really complicated functions. Certainly not in the 13,000 input version of this situation for our crazy complicated neural network cost function. A more flexible tactic is to start at any old input and figure out which direction you should step to make that output lower. Specifically, if you can figure out the slope of the function where you are, then shift to the left if that slope is positive, and shift the input to the right if that slope is negative. If you do this repeatedly, at each point checking the new slope and taking the appropriate step, you're going to approach some local minimum of the function. And the image you might have in mind here is a ball rolling down a hill. And notice, even for this really simplified single input function, there are many possible valleys that you might land in, depending on which random input you start at. And there's no guarantee that the local minimum you land in is.
So can you see now it says the local minimum cannot be reached, right? So I mean, depending on the starting point, we can either end in these 3 local minimum points, right? So it's like depending on where we are going to start, where the initial loss is, right? Where the initial loss is. So depending on the initial loss, we are going to end up with one of these 3 points, right?
Going to be the smallest possible value of the cost function. That's going to carry over to our neural network case as well. And I also want you to notice how if you make your step sizes proportional to the slope, then when the slope is flattening out towards the minimum, your steps get smaller and smaller.
Then now it says like according to the gradient descent algorithm, when the gradient becomes the magnitude of the gradient becomes small, the step is also the step that the gradient, I mean the weight adjustment is also getting smaller and smaller, right? So that means like it's readying for identifying the minimum. I mean it's like it's feeling that it's going to like reach a minimum point. The minimum point එක ළඟ වෙන gradient එකේ magnitude එක අඩු වෙනවා, right? So it says like it's going to slow it up, right? It's going to slow it up, and like we are going to make the small size smaller to reach the local minimum. I mean a minimum, right?
And that kind of helps you from overshooting.
Right? Understood. Right. Okay. So the next thing is I will show you the stochastic gradient descent. Right. The stochastic gradient descent. Right.
The way you would interpret with the same.
Okay. Right. So yeah. Okay. So in the stochastic gradient descent, I will talk about the stochastic gradient descent as well. So we are going like we are going to actually what we are doing is we are increasing the step size, and we are doing this random kind of weight adjustments, right? Random kind of weight adjustments. So that's how we are going to like yes, I mean reach the minimum loss, the minimum global loss, right? Uh, so I will share that video file with you as well, right? The video that I showed you, right? So here we have like good examples where you can take lots of things from that video. I mean, a graphical animation. Uh, I will try to show you uh, the the stochastic gradient descent video as well, where you can get a good idea how actually these things are working. Uh, yes, I will show you the original video and I will give you the link as well. Okay, I will show that video later. Now, what I want to highlight here, yeah, so you know about the gradient descent algorithm, right? And then I want to